Fine. So the ninth experiment will be calculator using Yacc. Now, what is Yacc? Yacc is similar to a Lex, a package what you have in C++, sorry, C. Now, this Yacc is yet again compiler. Now, what does this do? This takes in the context-free grammar as such as input, okay, and tries to construct an LALR passing table. That is look ahead LR passing table. And then once that is done, the first part is to take in the context-free grammar based on LALR passing table. A passing table as such is being constructed. And then it requests your Lex analyzer. That is, you are using Lex. It tries to take in, read the token by token from the input what we are giving, tries to check whether the token is correct and fits it into your LALR passing technique. As soon as and when it checks the syntax is correct, parallelly it performs certain job. So that job will ensure that, or we'll write it in such a way that it tries to evaluate the arithmetic expression. And therefore, as and when I check whether the syntax of your arithmetic expression is correct, I'll be also in a position to evaluate the expression, and at the end we'll be getting the value for it. So having said that, this is the program what we are going to take in as input. We'll say we are going to, this is the context-free grammar which we'll take in as input. Along with this one, it takes in any digits, maybe 2 plus 3 star 5, 3 star 5 slash 6, whatever it is. Fine. So the highest priority goes to anything within parentheses or the digit what we are giving as input. And then the next priority goes to the star and the slash, that is division and multiplication. The least priority goes to plus and minus, and then we are going to consider it as a line. So what are we going to really do is, let me take your program and explain it. As we had it in our, in your Lex, here also we have a declaration statement. And that declaration has to start with percentage opening parenthesis. I can include any number of libraries which I need. And then we are defining YYS type to be of double. Fine. So the type what we are going to use here will be double, and that is we have defined it. And then we are going to define finish off the declaration of the header and the variables. And then what I have done here is I have ended the declaration part itself. Now in between these two lines, if at all you have to give some names for the regular expression, you are welcome to do so. Fine, but we haven't given any name for the regular expression, and therefore we have stopped it. Now what are we going to do, or how are we going to write it? If you see here, you will have a left hand side for the production as well as the right hand side for the production, and in these two are separated by an arrowhead. But here what are we going to do is the left hand side will be given here, and the separation between the left hand side and the right hand side would be an colon symbol, not the arrowhead. So instead of arrowhead, you will have a colon. So now what happens here is you take something as input, which can be blank. So nothing is given here, or it can be input with a line. Fine. And then you end off this particular production. So you have a semicolon here. And then you have a line, colon, it accepts any new line, or it accepts an expression with a line. If there is an expression with a line, then what I am supposed to do? I am supposed to do certain job. So what you have here is you are trying to print the value of it. Fine. Now we'll say, where will I get this value from? This value is associated with something called as expression. So now moving on, I'll go from below. Okay. All the digits I have taken it as taken here. So what is this dollar? Dollar represents the value associated with the left hand side variable. This left hand side variable has certain values which can be associated with it, which we'll be learning in the coming week. But then as of now, for your understanding, every of the non-terminal will be associated with certain values and certain attributes. Now, every of the non-terminal will be associated with values. So how do I define the attribute associated with this non-terminal? That is $. Any non-terminal, what you represent, which comes onto your left-hand side of the production is represented as $. So when I read 0, $, will be assigned in value 0. When the system reads 1, the $, that is this digit value will be associated with 1. So when you say 2 or 3 or 4, it is converted to digit while reduction. At the same time, you have the value assigned to it. So digit will just assign the values. Now we had something called as star and slash and so on. Now what happens here is you now this one is for an what to say, if you have 23 as such, then you take it as num. Okay, so now what am I supposed to do? Either I take the value and assign it to digit, okay, digit value and assign it to num. So now what happens here, some value is associated with num, some value is associated with the right hand side variable. The first right hand side variable will be considered as $1. The second character would be considered as $2. The third would be considered as $3 and so on and so forth. So now what happens here? You are taking $1 and assigning it to $, which is the value associated with num. Now, if I have num and a digit, what do? I have to take this value, multiply it with 10 and add it with this one. So how do I represent this one? This I represent it by $1 and this I represent it by $2. So what do I have here? $1 is multiplied with 10 along with you add the value of $2. Now both these are assigned to the left hand side variable which is represented by $. Now here you have 3 cases. Okay, the num as such we are assigning it to factor. So you say $, is $1. Here you have 3 cases. If it's term produces factor, then you just do an assignment. If it is term produces term slash factor, this is $1, slash is $2 and factor is $3, and therefore we have taken $1 slash $3 assigned it to term. Similarly, $1 multiplied with $3 assigned it to $. The same explanation goes here. If it is addition and subtraction, you do it and assign it. If it is just $, you assign the expression produces term, you just do an copy statement or an assignment statement. Now, once you give 2 plus 3 enter, then you have to do some evaluation and print it. When you see 2 plus 3 enter, automatically the parsing happens and checks whether the 2 plus 3 is valid, and then you have an value 5 which is produced for the root node of your tree, syntax tree. So now what happens? You have a value there. That expression 2 plus 3 is reduced to expression as such, which has a value 5. When I give a new line operator, you have to print something. So you try to print the value associated with expression. If it's just a new line operator, there is nothing to be printed, fine. And this is just to have an input statement. So this is how it works on. So this is the next part where you have a set of productions as well as a set of actions which has to happen. Anything which is given within the parenthesis is the actions, which you call it as semantic actions or translation rules. The other one, the left, anything with this colon or operator, so on and so forth, is the set of productions what you are writing in Yacc format. Every production has to be ended with a semicolon. And then once you finish the second part, we have 2% symbol. Now we need lexical analysis because your YY parse gets token by token, and therefore we are defining YYLX to return every character that what you are giving in as input. So return get character, and in main method we'll just give whatever the parser gives us, we are going to return it. So you'll call YY parse and you return the same. You also have YY error. If there is any error, we'll say % error. So you have, I think YY, we don't use YY wrap here, we use YY error. We know about YY lex, you have YY pass. Now, if you given the input, it works. Now, how do I save this program? I save the program with the extension of Y, any name with .y extension. Now, how do I compile it? I compile it using the command Yacc, which creates invariably y.tab.c. Whatever is the name given to a Yacc program, on compilation, the Yacc compiler will give you y.tab.c, which you can use here GCC or CC compiler to compile it and execute it. Fine. Here you have something called as -c in the document what I have uploaded. Now this -c is just for compilation. Fine. Here what the -o indicates is you are trying to take in the object codes and you are linking it. Fine. So all you are trying to take the object code y.tab.o and lex.yy.o and you are linking it, and then your normal procedure happens. But we'll never use all this. We'll just use Yacc filename.y and then cc y.tab.c, which moves on. Now, how do I really do it? Is by using code.karunya.edu. Fine. So what I do is I have a program called bi-yacc1.y. So I'll just go ahead. You say I have given in all your 1 second. I have given in all the header variables. I have defined it, and then I have given the same set of program what I have explained you. Fine. Once that is done, what you do is you have Yacc yacc1.y, and then give an enter. Your y.tab.c will be there. So I'll say cc y.tab.c and then /a.out. Now if I give 3, once you give an enter, you have the answer for it. If I have to quit it, give it as Control-D. Fine. So this is what is expected of you to do today. I think if you have any clarifications, you can ask me now. Else you can start doing your work. Informations have been uploaded onto your Google Classroom. You can start doing your work.